Okay, so all you're really trying to do today, 24, 25, 26, these are separate things where you just watch a video and see what you can see, and this is just a plug and chug kind of formula. But what I want you to be able to do is fill in these forces. And to do that, you're going to use the videos to come up with this net force here, and the net force here. And once you get those two net forces, then you can do some other things. Like during the deceleration phase, when this car is slowing down, you know the net force and the force of friction are the same because there isn't any other force. There's only one force acting on it, so it's equal to the net force. And that's the force of friction. So whatever you come up with here, if it's 2, this is going to be 2 also. This you're going to be able to calculate from the video. This one you're going to know because it's the same as that. The force of friction in both of these situations is the same. Force of friction in the beginning and the end. So whatever you got here, you put it there, you put it there. And then the very last part is you just have to use your brain and figure out what that one is. But if you know this net force and you know that force, then you can do that. It's just like the things similar to what was on the homework just now. So I'm going to show you how to get this net force, and then you can really take it from there. I don't think you need me talking at you any longer than that. So what I'm about to do is go through these steps. If you look on this side, 5 through 12, the last thing you arrive at is what is the net force during acceleration. And then 13 through 20, you do the same kind of stuff and you get the net force during the deceleration phase.
Are we writing this all on papers?
No, just follow along. But it is necessary for me to do this or you're going to be really confused. Is there anybody who would be willing to calculate things for me? I'm going to be writing on the board. I need somebody to calculate, so I don't have to be doing that for this. Okay. So I've decided, just as an example, we'll use the fast car video. I've actually been using your video for the other classes as just a practice. Not your video, but your spreadsheet. It's a good one. It's easy. It's got a nice graph. It gives good results. Pretty easy to analyze. Okay. So in order to do that first part, you've got to have this thing set up. Your data is not going to be this voluminous. Most cars didn't go this far. This car went 12.5 meters, and then it hit the thing in the back. So it would have kept going. I don't know how far it would have gone. The first thing to do once you get this is to find where you hit the maximum velocity. I'm going to zoom in here. I don't know why the numbers look so, the font looks bad. But I'm going to go down until I get to, in this column, the velocity column, until it gets as high as possible. And it's right there. Now I'm going to highlight this row. You don't have to. It just makes things easier if you highlight that row. This is, and now I'm going to start filling stuff out just like you would. Number 5 on this says starting velocity for the acceleration phase is 0 seconds. I screwed up. It's supposed to be 0 meters per second. If you look at their graph, let's see if it really looks like that. Notice how the graph doesn't really go down to 0. This is velocity. It doesn't start at 0. But we know it does, so let's just put 0 in for the starting velocity. And at the end, theirs doesn't ever get back to 0. On the end, let's just stop at this last point. But at the beginning, let's start at 0. So, got that. Number 6, final velocity for the acceleration phase. So as the car is speeding up, it's speeding up, speeding up. Tell me when I get through the acceleration phase. Tell me when it ends. You missed it. No. It's accelerating. Tell me when it stops accelerating.
There.
Right there. Because then the speed starts to go back down. So if this is the acceleration phase, what's the final velocity for that part of the trial? 4.88. That is the final velocity is the maximum velocity. We're analyzing what is the force acting on the car right in here and it's speeding up. 4.88 meters per second. And the ultimate goal is to be able to use this equation, change in velocity over change in time, to get acceleration. And then from there we can use F equals ma to get the force. So this is just collecting data for that. The starting time for the acceleration phase is 0 seconds. So it starts at 0, time goes up, 0 seconds. What's the ending time, final time for the acceleration phase? What's the time at which it stops accelerating? 1.72. Change in velocity during the acceleration phase, this is kind of a no-brainer. We're just saying this was the velocity in the beginning, this is the velocity at the end. What was the change? 4.88. Now it's going to be a little more complicated when you do the deceleration phase, because the velocity here is 4.88 and then it drops down to 1.464. So in that case you're going to be subtracting to get the change in velocity. Here you can just say it started from 0, went up to 4.848, so that is the change. But this minus this is just that. 4.88 meters per second equals the change in velocity. Number 10, change in time. What's the change in time? During the acceleration phase, how much time went by? 1.72. It's just this again. This was the starting time, this was the ending time, this minus this is just that. 1.72 seconds. Number 11, average acceleration. Now I've got to use this formula. I'll leave this on the board in case you've forgotten, because I didn't tell you how to memorize it. Change in velocity over change in time. The change in velocity is 4.88 meters per second squared, or sorry, meters per second. The change in time is 1.72 seconds. Carry. 2.837 meters per second squared. That is fast. That's the fastest acceleration I've seen of any of these cars. So that's the acceleration. Now number 12 says net force during acceleration phase. Use the second law. The second law is F equals ma. So we have A. Those people are whispering. Are you going to know how to do this?
I'm really distracted.
So that's the acceleration. The mass you're going to get, there's a digital balance in back. Set it on the balance. That's going to give you the mass in grams. On here it says up at the top, convert it by dividing by 1,000. Let's just say that the mass is 0.2 kilograms. So Carrie, what is 0.2 times that?
0.567.
And I'll just call it 0.57 newtons. So there, we've got it. So that would be that's the force acting on the car, the net force acting on the car during the acceleration phase. If that were my car, I would just go up here, find the acceleration phase, and I'd write 0.57 newtons. Then the next part is to do the same kind of thing for the deceleration phase. It's a little more complicated because you're not starting at 0 with either velocity or time. You're starting at something else. And you're not necessarily ending at 0 either. A few other things. Take these measurements of your car. The wheelbase. What I mean by wheelbase is the distance from one axle to the other, or where one wheel touches the ground to where the other one does. So this is the wheelbase. And all these things you're measuring, we'll go over why later on, but they're going to be important in understanding how your car functions. Just off the bat, would you guess it's better to have a short wheelbase or a long wheelbase for these cars? Longer is better on these cars for two reasons. One is, if you have a rubber band kind of thing, the longer you stretch that rubber band, the more energy you can put into your car. If you have a little short car, you've got to figure out some way to put a lot of energy into it. The other thing is, if you're turning a car, if you want a car that turns sharply, do you want a long car or a short car? Short car. I've got a My wife has a Prius that we drive around a lot, and we can turn really sharply in that. And I've got a big long Silverado crew cab truck, and I couldn't turn around. From this wall to that wall, that's about how much space I need to turn around and do a circle. It's ridiculous. But with these cars, do you want them to turn sharply? No. So if you have a really long car and the wheels are angled a couple of degrees, it's not going to curve much. If you have a really short car and the wheels are angled a couple of degrees, it's going to curve a lot. So those are just a couple of things related to the wheelbase. Everything I'm having you put on here is going to be in some way important later on, but I don't have time to explain it all to you. Photographs, I'm going to be going around taking pictures of your cars. If you want to take your own photographs of your car, you can do that. Just get a top view, side view, front view, perspective view. If you want me to do it, I'll put them on the iDrive, and I want you to just save those pictures in your folders sometime. The radius, when you're measuring the wheel radii, make sure you measure this distance, not the diameter. And then again with the mass, you just use the balance back there. So go to it, see if you can get all this done. Some people who still need to do the videos, we can do that.